This is exam 3 for ECE 202. This is a closed book, closed notes exam. Before you do this exam, you should have viewed the videos for the material up to and including chapter 13, page 17. If you haven't done this, don't look at this exam until you've studied that material. Now let's go over the exam and you'll have 60 minutes to do this test. Problem number 1 has several parts to it. Here are some questions to answer and some calculations to do. The first one is to answer the question, if a circuit is stable, what can be said about the natural poles of this circuit? Please answer in a complete sentence. Next, what is the meaning of the word port? The third problem, given the impulse response, 4 times e to the minus 3t times u of t, can use the convolution integral to find the zero state response for x of t equal to 6 times e to the minus 2t u of t. And lastly, given a series RC circuit where R is 6 ohms and C is 5 farads, if you were to magnitude scale this impedance by a factor of 68,000, what would be the new values of R and C? Problem number 2, given this op-amp circuit, can you find the voltage transfer function in the S domain, V out of S over V in of S? Then next, can you find V out of T, given that the input is a step of 100 millivolts? For problem number 3, given a transfer function in the S domain that's equal to minus 30S over S plus 100, could you plot the magnitude of this voltage gain in dB and also plot the angle versus omega? I'd like you to make your own log paper and plot the forms using a dashed line and the final plot with a solid line. Label all your final slopes and levels. Then in the last problem, given the following waveform, can you determine if there is no symmetry, odd symmetry, even symmetry, and or half wave symmetry? I'd like you to use a single point to argue whether you have these types of symmetries or not. And this is exam number 3. You can find a copy of this exam in the ECE 202 ebook by looking in the bookmarks towards the end of the ebook. Print a copy of this exam, and you have 60 minutes to do it.